All right, thank you, Catherine. I'm going to put up an agenda slide here real quick just to cover the items we're going to go through today. We're just going to do some cut-fill calculations, and we're going to talk about how that gets set up properly to run. And then we'll do some reports on those calculations. Then we're going to go through end area volumes and annotation there. And then at the end, we're going to create a mass haul diagram. So there's what we're going to do. Let's jump right over into the product and get started. The data set, like Catherine said, is down in the resource list if you need to pull that. What we're going to be doing, we're going to be starting basically from scratch and then using the designs that Joey and Scott have done over the past 4 weeks. So just to remind everybody, we're going to be spending time in the training examples workspace, and I'm using the training Imperial work set. And the first thing we're going to do is we're just going to create a new file, and I'm going to put it in our session 6 data, and I'm going to put it in the corridors folder. And I'm going to call this file volumes. That's going to contain all the volume data that we create there. I want to make sure that I'm using a 2D seed file. I'm going to start with 2D. I'm going to let the program manage the 3D for me. So using that 2D seed volumes.dgn, and we'll hit save, and we'll let that load up. So over the past 4 weeks, Joey and Scott have been doing all the hard work on the design here. They've created the horizontal and vertical on our project here. They ran the corridor modeler down and created the basis of the corridor. And then they came in the next week and they did the intersection design, a median crossover design, and then last week Scott did the bridge abutment design. So the design that's taken place to this point has been a mix of corridor modeling, linear templates, surface templates all on the slope. All that has been done here. So the first thing I'm going to do once I get my DGN up here is I'm going to reference in all the design that they've done there. So I'm going to go to my attach tools and attach a reference. And I'm going to attach that finished corridor. So the file I'm grabbing here is Highway 72 corridor mainline finished. And that, we'll go ahead and say open on that. I do want to, in the live nesting, I want to change the nesting depth on that, get a little deeper there because I've attached some other design that we've done there. So I'm putting 10 in as nesting depth. Say OK on that, and that'll bring in the design that we've done so far, most of it. We'll do a fit and look at that. Just here in 2D, we have the corridor design that was done. A reference into this corridor file is the intersection and the median crossover design that was done. Also in this file here, we have the bridge abutments as well. So while I'm looking at that, I'm just going to hit element selection. I'm going to set that terrain active. And what that does for me is as soon as I set that active, the program is creating the 3D model for me, and it's going to start handling all the managing of the 2D, 3D stuff for me at that point. So I just set that active to get that set up. I'm going to go back to the attach tools. I have most of the design components there, but I have some other 3D information that are going to help me with my volumes that I want to attach there. So I'm going to go to Tools, Attach, and I'm going to go to the terrain folder. So back in the section 6 data in the terrain folder, I've got 2 other DGNs that are important to me when I do volumes. I have my existing pavement. Scott went through and modeled some existing pavement there. We're going to classify that as unsuitable material that we're going to dig out. And so we've got that modeled as a surface template there in existing pavement. And then I'm also going to select a rock limestone DGN. And so we are, this is modeling a area where maybe our geotech team has come and told us we have kind of a limestone surface 3 to 5 feet below the surface there, and I've got that modeled in that DGN file. So I'm going to hit open to attach both of those and say OK on that, just taking all the rest of the defaults. And then once we have that attached, let's just take a look at what we have. I'm going to right-click in my view there, go to View Control, and choose Two Views, Plan, and 3D. Okay, so let's just zoom in on our roadway and look at a couple of things. The first thing I want to look at is we have our design. I can see the corridor that we created earlier. This area here is the existing pavement that we modeled separately. So this is coming in from that existing pavement reference. If we look, my existing ground surface doesn't have triangles on right now, but it's there, it's present. You know, the volumes will be able to use it. If I look, let's zoom over a little bit in 3D. If I zoom in on this, I can see that existing pavement is actually up above where my design is. So I'm in an area of cut here on my roadway. This existing pavement is, if I had my triangles turned on for my existing ground surface, we'd see that the existing ground surface runs over the top of that existing pavement. It's a good existing ground terrain. So we have our existing pavement there. We have our if we rotate it this way, we can see that here is our area where we have some rock strata modeled. And again, that's, again, you can't see the existing ground, but that's all about 3 to 5 feet below existing ground in this area. So we're going to want to account for that in our volumes. And then when we get to the area of the intersection, this is where I want to, again, repeat that the work done by Joey and Scott in modeling this, they use surface templates in this area to model the depth of the pavement. And to do their modeling, they didn't use corridors and components in it. But as long as, since they use those surface templates, we have 3D depth on their components here. We're going to get good volumes from this. And this is Scott last week when he did his bridge abutment. He used some linear templates. He used some surface templates. He used different methods. So it doesn't really matter what methods you use when you're modeling. As long as you get a good 3D model in the end, the volume calculations will query the 3D. So it's kind of a, you know, the more time and the better your 3D model is, the better your quantities are going to be. Okay. So there's just a look at it in 3D. And I'm going to go ahead and run the command real quick. And then after we run the command to create our cut fill volumes, we'll take a step back and actually look at the setup that occurred for that. So really, once the 3D model is done, and it's done, we've got it all attached in, I'm going to go to Home. I'm going to be working a lot in this analysis drop-down today, and I'm just going to go straight to Create Cut Fill Volumes. And our Create Cut Fill Volumes dialog comes up. I'm going to go ahead and choose the selections here in the dialog instead of doing it in my heads-up display, just so I can point to each one of them with my mouse. What's going to happen here is when we create cut fill volumes, we're going to start at the existing ground, and we're going to go up to the design or down to the design, and we're going to create some new 3D meshes, some closed 3D meshes here in our 3D model. The meshes are going to represent the volume of cut, the volume of fill, so we're just telling it which feature definition to use, how we want those to look, and some other properties about those cut and fill meshes. We are turning on, we do want to use unsuitable materials. I do have that existing pavement section in here, that reference attachment here as an unsuitable material. We're not, in this data set, I don't have any custom volumes defined. We'll talk about that here in a second. We go through the different volume options. I do have my substrata. I do have my rock surface modeled in here, so I'm going to turn that on. And then it's asking when it creates a shape, when it creates my 3D mesh representing that rock cut, what feature definition do we want to use to represent that rock cut? And so we're using TC rock surface feature definition. So these are filled in for me by default. If you are in this for the first time, you might have to just hit the drop down there and browse to the right feature definitions, volumes cut and volumes fill for my cut and fill feature definitions, and then TC rock surface for my substrata. So really, once you fill out that dialog, make sure your feature definitions are set. Make sure you're telling it to use which components you want to use. It's just a matter of we're going to accept all those prompts, and we're going to let it run here for a minute. So, and it popped up on the screen. I'll drag it over. So it's going to give you a status bar showing you what all it's doing. Like I said, it's interrogating the 3D model. It's starting at the existing ground. It's going up to find any design surface. If it finds design surface above it, it's going to put a fill mesh in there. When it goes down and looks for a design surface, it's going to put a cut. When it goes up and finds it, it's going to do a cut. When it goes down and finds the existing surface, it's going to place a fill feature in there. It's also looking for any unsuitables that it needs to calculate, and it's also looking for that rock surface so we can quantify the rock. So we'll let, looks like it's doing the last process there. And what's going to happen when it's completely done is I'm going to have new 3D meshes here in the 3D of this file. So currently, I have nothing in this file. It's only, right now, I've only referenced in the design that we've done previously. So there's actually no elements in this file. So after I get done with this cut fill command, I'm going to have 3D meshes here in my 3D model. And we'll let it finish processing here, and we'll take a look at those elements. What it's done, like I said, it's created those closed 3D meshes. So I have, now that the command is run, I have a physical representation of the cut, the fill, the unsuitable, the rock strata is all now drawn in the 3D model for me. So when I do volumes on it, I'm getting a true 3D prismoidal volume of all the different materials that are drawn in here. So let's just take a look real quick. Let's go to the reference tools, and I'm just going to turn off my 3 attachments real quick just to look at just the elements that were created in the design file. So I've got those references turned off. So what we're looking at in the design file here is just those 3D elements that were created. So just for reference, my yellow element here, that's that existing pavement that I deemed unsuitable that had to be removed. The red is my cut shapes. The blue are my fill shapes. This gray is where I'm doing some rock cut on that. So now I have a true 3D representation of the cut, the fill, the unsuitable, the rock that's going to be quantified on this job. If I click on any one of the elements, I can go to the properties in over here. I can look at the properties on it, and I can get volumes right off. So I'm doing some inspection on what the program has calculated here. I'm doing some visual inspection in the 3D. I'm going to look at my volume numbers over here by just querying the volume of that element. And then I can also maybe take a quick look at it in cross-section view. So let's do that real quick. Let's, in our attach tools, we're going to turn our reference back on. This has all of our design components back in it. So I'm going to go and go into the corridors ribbon up here, and I'm going to create dynamic sections here. I'm just going to create dynamic sections along our corridor. Pick our corridor, and we'll open up view 3 for my cross-section view. Okay, so like I said, since these are 3D meshes sitting in this design file, when I use my dynamic section command to cut a slice through my 3D model, I'm getting a slice through those cut and fill shapes as well. So here, just at the beginning of the job, we can see we have a little bit of fill where my design is above the existing ground. We have a little bit of cut on the other side. Remember, our yellow shape is that unsuitable existing pavement that we're removing. Let's go down and take a look maybe where we have some of that rock strata. I'm going to say locate station via data point, and going to data point, we'll just cut a section right there along our roadway. Here we have my rock strata, and that's this gray area that's, like I said, some distance below the existing ground. So any area where I have cut out of that strata area, I've got a shape for the rock surface there. Let's go now to maybe where the intersection was designed. I'm going to again say locate station via data point and plan view, and I'm going to cut a section just right down that driveway or that intersecting road. And we can see that where we did the design and the median, that was done, we did the corridors over here, and then we did surface templates here in the median. We did surface templates over here, but since those surface templates have, have pavement buildup in them, we have those different layers showing up here, and we have cut and fill for all those elements there as well. Let's take a look at one more section. Again, I'm going to right-click. I'm going to choose Locate Station via Data Point. I'm going to go down into our where we're modeling that bridge abutment a little bit. I'm going to go about halfway down the slope and place a data point. And what I wanted to show here is, I'm almost down near the bottom of the slope, so I have a little fill here that it's modeled for me. And you'll see that the bridge components are up here up top, and they don't have any volume. I'm not doing any fill to get up to those bridge components. So it's smart enough to know to not include that bridge. So that's what I want to talk about now, is how is the program smart enough to know what is design, what is bridge, what is unsuitable now. And that's all controlled in the feature definitions. So we're going to take a minute here and just look at the feature definitions and look at how they tell the model how to calculate volumes. So let me just clean up my views a little bit here. I'm going to put the 2D up there, move my cross-section down, get it out of the way. Okay, so we'll go look at feature definitions now. To do that, I'm going to go over to the Explorer, and I'm sitting here in the Open Roads Standards portion of the Explorer. In our standards is where we store all the feature definitions, and the first one I want to look at, since I don't, I just referenced in the existing ground in the file, so the existing ground feature definition is not actually in this DGN, so I'm going to go look at it in the list of libraries in the DGN lib and see how that's set up. Like I said, everything's kind of, it's looking at that existing ground. It's comparing the location of the design to that existing ground to know whether to place cut or fill. So it's important to know how that existing ground is set up. So I'm going to go libraries, feature definitions here, and in terrain, existing, my existing ground is using existing boundary. So when I highlight that, I'm going to go look at the properties on it. And I can see down here at the bottom in the terrain section in the feature definition, it says, what is my volume option? Well, my existing ground is an existing volume option. So that tells it this is existing ground. Anything above is fill. Anything below is cut. So existing ground has an existing volume option. Now let's go look at one that is a design type feature definition, and those are in my DGN file. So I can go to feature definitions. The meshes that are created by like the templates in our corridor model or by the surface templates have feature definitions here. And let's look at concrete and maybe concrete pavement as an example. So my concrete pavement has a volume option of design. So it knows, again, it looks at the location of the design components in comparison to where the existing component is to know cut and fill. So all of my pavement, my slopes, my shoulders, anything that is a design component, anything that's going to, that I'm wanting to model and to get volumes down to is going to have a design volume option. Okay, next let's go look at the existing and the rock surface. And that's the surface here that's modeling the top of our limestone. And that has a TC rock surface as its feature symbology. That's telling it what it wants to look at. But the volume option there is substrata. So that's telling it that anything above that, anything between, or I'm sorry, anything below substrata. So anything between existing and substrata is just going to be unclassified dirt. It's just going to be our regular cut and fill. Anything below substrata, between substrata and design, that's going to be rock cut. And we need to know what the cut factor is on there. So what's the swell factor on that rock? So we can enter in cut and fill factors on substrata. And then also, while we're talking about cut and fill factors, on our, let's go to our cut and fill feature definition. Those are down in volumes in this DGNlib. Our volumes cut those are the red meshes that were created there, and we have the volume option is cut, and we can do a shrink swell factor there if we need to for our cut factor. And then volumes fill is the same thing. It's going to have a fill option here. So let's just look real quick at the different volume options, make sure we've covered them all. So we have design. Again, that's our pavement, that's our slopes, that's anything we want to calculate cut fill to. Our existing is our existing ground. None, that's one we didn't talk about. That's one that we used over here in our bridge section. If we see our bridges are not included, that's because they have the volume option of none. Okay. Subgrade is very similar to design. That would just designate the bottom of the design. This would be used if we're importing any terrains or importing land XML that represent the subgrade design. We can give that subgrade, and that's going to act a lot like design in that it's going to calculate the area between existing and subgrade as cut and fill. So that's something you're going to use on your terrains. Substrata, that was what we assigned to our rock surface there. Cut and fill, those are the what I'm calling unclassified cut and fill, the area between existing and design. And those we can put shrink and swell factors on them. Unsuitable and custom. Let's go look at an unsuitable feature definition real quick. And we have here this existing pavement. Like I said, how we modeled our existing pavement out here, we use that. We use this TC existing pavement feature definition for it. And if we look at details on it, we have even more options now. The volume option is unsuitable. So when we cut this out, it's not going to go into our mass ordinate. We're not going to use it as a cut and fill that we can use elsewhere on the job. It's unsuitable, right? We've got a cut fill factor on it. And then we have the ability to split when we quantify it, we have the ability to split what gets removed only and what gets replaced. So if there's any reason when we remove unsuitable, but we have to put some back in because it's underneath a fill, we can quantify that separately from the total amount that was removed. So we didn't see this with the other volume option types. We didn't have this split here, but with unsuitable we do. We can classify differently what gets replaced and what gets removed. And then I'm not using it in this demo, but we do have a option down here called custom, and custom. Let's see if I have one already. Let's go to structural grading. Nope, I really don't. But let me just I'll just show you on one. If we choose custom, a custom is a type of design. I would call it a design feature definition, and this allows you to quantify your, like a structural fill. Back in En-ROADS, we had moisture density control, MDC, where it's a closed, what you're going to have in your model, you're going to have a closed design shape, and it's going to allow you to split that and to show what gets removed and replaced. So this is going to be like a structural fill where you have to use some kind of select fill. This is going to be moisture density control where you're removing a certain amount of existing ground underneath. And so what this does is it allows you to split what's above and what's below the existing ground when you quantify it there. So it's kind of a subtype of a design type volume option, but it allows you to do this split above and below existing ground, what gets removed and what gets replaced. Okay, so we'll set grass back like it was as design. And I don't have any custom types in this data set. If you want to play with it yourself, I would encourage that. Okay, so we have feature definitions. We have feature definitions assigned to all of our 3D shapes in our 3D model. So since these 3D elements had feature definitions on them with volume options, the program knew what to do when I ran the create cut fill volumes command. It knew. It looked at every mesh in the 3D. If it had a volume option, it acted on it and it created a cut and fill mesh. It's kind of a one button command there, and that's how we got our cut fill meshes there. So okay, the meshes are there. Now how do we do some reports on that, right? So the first report I'm going to show, again, we're back on the Home tab. We're in the Model Analysis and Reporting section on the ribbon. And we're going to hit the drop down there. And I just want to get a quick quantity of everything of all the 3D meshes that it threw out there for me. So I'm going to do quantities report by name boundary. And you'll notice I don't have any name boundaries yet. So I'm going to say none for my name boundary group. And I'm going to turn off right now. If this was on for me, if it was on for you, go ahead and turn it off. We're not going to do any clipped graphics right now. We're going to do that in just a few minutes. But right now, I just want one report that gives me all the quantities I just calculated there. So I'm going to accept no name boundary and no clipped graphics. And this is just going to report on all those 3D meshes that were created with the cut fill tool. And you'll notice it's reporting on more than just that. It truly is that quantities by name boundary truly is a quantities report. It's giving me everything in the model that has a feature definition on it. So if it was a point, it's giving me the count of the number of points. If it was a line, it's giving me the length of the line. If it was just a shape, it's going to give me an area. And if it was truly a 3D mesh with a volume, it's going to give me the volume there in my. So this is truly a quantities report for everything in the model that has a feature definition on it. Everything that the program knows is a part of the civil model, it's going to give me a report on that. So I'm going to get areas, I'm going to get volumes, everything here. If I want to look at just the volumes themselves, I can come down and use the volumes.xsl. And again, since this is XSL, this is formatable. You can change columns, change headers, change information that's being reported. And also, since it's in the report browser here, I can make use of the format options where I can say, you know what, my cubic units, I do want those in cubic yards. Some of you may have to come here and toggle that on. If it's off, it's reporting them in cubic feet here in my Imperial data set. So I turned on convert to cubic yards, and really with cubic yards we really don't need decimals, so I'll set that down to a tenth on my volume. So there I've formatted it to cubic yards and to just a tenth of a cubic yard. And again, this is you'll notice my unsuitable material there, my existing pavement. I was splitting that up. So here's my total unsuitable material on the job, and how much of it does not need to be replaced, and how much of it has to be replaced, back under a fill there. My volumes, my unclassified, what I call unclassified cut and fill, just the dirt cut and fill, that's here, volumes cut and volumes fill. You notice that everything is being reported based off of the name of the feature definition. So the feature definition is critically important here in our volumes calculation. It not only tells it what type of object it is, it also tells it when it comes here to be reported, we're often grouping by the feature definition itself. So here's my cut and fill, and I get totals down here if I wanted to see what the total cut and fill were on my job. So that's the quantities report by name boundary, and that's just giving me the full volumes. So these volumes, full prismoidal volume of all the elements in my DGN. So if I want to, there's a lot of power that I can use with in the drawing production by using drawing boundaries, named drawing boundaries, and we're gonna switch over to a different DGN and start doing that. And since I wanted to show the ability of the program to do that clipping that we'll see on a lot of these volume tools. So I want to go to a new DGN that doesn't have anything in the 3D. So what I'm going to do is just switch DGNs right now. We're going to go to File, Open. We're going to browse to the not the corridors folder. We're going to go back up to Section 6 Data. We're going to go to Sheets folder. And in there I have a blank DGN waiting for us there. It's just got, I think the only thing I did in there was just set up go ahead and have a 3D model waiting for us. So I'm going to open up that file. That was Highway 72 volumes, eastbound, westbound. So we're going to use some named boundaries here to split up our volume calculations and quantify them a little differently. Okay. So when this file, like I said, this is just an empty file. I'm going to attach to it. The only thing I'm going to attach is that volumes.dgn that we just did. I want those design features in there, and I also want those cut and fill quantities, unsuitable quantities, and rock quantities there. So I'm going to go back to the corridors folder, and I'm going to reference in the volumes. But what we're going to do is we're going to split up all those volumes, and we're going to report on them a little bit differently now. So I'm going to say open. Again, I'm going to make sure it gets all those nested attachments. I'm going to set that to 10 and say OK. Okay, so if I need to report on volumes by station, that's a requirement on a lot of these road jobs. Then I can split up the quantities by station by using the name boundary tool. So what I'm going to do here is I'm just going to come down one side of the roadway here, and I'm going to report on, maybe I have some kind of weird funding situation where the eastbound is funded differently than the westbound. I'm actually going to split up the quantities here, eastbound and westbound, in different quantity reports, and I'm going to divide it by station. I'm just going to, in this example here, I'm probably going to use 200, 500 feet, something along that lines, just to show how the quantities can be split up there. Okay, so to do that, I need my name boundaries to show where the different volumes are going to be split up. So I'm going to go to Drawing Production, and I'm going to create new name boundaries. And I'm going to split up eastbound from westbound, one side of the road from the other, and I'm going to do it at a specified station length, okay? So when that comes up, I'm going to go to the first one, Civil Plan, and create some plan name boundaries. And all I really want here, I don't want any drawings or any sheets created from this. All I want is the boundary itself. So for drawing seed, I'm going to say none. And let me go ahead and pick my plan element, which is just the center line of our road. Okay, for the name of our group, I'm going to call this Highway 72 eastbound, westbound. And we're going to do the top, which I think is the westbound side first. So we're going to do the top portion up here. So that is, we're going from lower station to higher station. So that's on the left side of the road there. So I'm going to say that my left offset is minus 200. And I'm going to say that my right offset is 0. So this is going to give us half of the design, starting at 0 and going left 200 feet. And for stationing, I could key in a specific station range that I want. What I'm going to do is I'm just going to go into this area here where we don't have any quantities in between the two sides. I'm just going to start here, and I'm going to place my, I'm doing it at length of 500 feet. So I'm going to do 500-foot stations of quantities there. And I'm going to place those 4 named boundaries. I'm going to turn off the create drawing. Again, I don't want the drawing. I just want the boundaries to help me quantify this. So there, I've got my left side name boundaries, westbound name boundaries, and I'm going to accept to place them, and it places them there. And then let's just do the same thing along the eastbound side. Going to pull up that dialog again, choose my path element there. This time I don't want to create a new group. I want to add these name boundaries to that same group. But this side of the roadway is going to be eastbound, and that offset on the left is going to be from 0 to a positive 200. Okay, and then not creating a drawing. Just want the boundaries there. So again, I'm gonna go in and start at the same station. I don't remember what station I chose, so I'm gonna snap to the end of that boundary that was created previously. And then I'm just gonna place the 4 same boundaries on the other side of the road, place the boundary, and accept. So there I have one name boundary group that has eastbound and westbound name boundaries on it. So now when I go back to the go back to home, go back to civil analysis, and go back to that quantities report by name boundary. Now I do have name boundaries, and now it is going to split up the quantities for me. So I'm going to do quantities by name boundary, and here's the name boundary group that I created, and I added both sets of name boundaries to. And then on this one, I want to make note here. This is the time where we're going to turn on, yes, display clipped graphics, and then we'll show what that does there. And you'll see a lot of these volume commands that we run have this option to display clipped graphics, and that gives you the opportunity to have a physical mesh representation of what was calculated there. So that's very powerful, a good QA tool there, and we're going to turn that on and display the clip graphics. So there I'm going to accept those 2 prompts, and it's going to go through, again, it's going to give me the Prismodal volumes of all of the closed meshes. It's going to give me surface areas of all of my shapes. It's going to give me lengths of all my lines. Anything that has a civil feature definition on it is going to be quantified in this command, quantities by name boundary. In this case, they're all going to be split up per sheet or per station range. All right, when that gets done calculating, it's given us 4 the different station ranges, and I didn't take time to type in the even station range. It just took what I data pointed. But every 500 feet, here's my eastbound volumes. It's giving my eastbound cut and fill, and then it's giving me my westbound cut and fill at that same station. And it's, again, this is quantities by name boundary, so it's giving me the quantity of every feature. If I just am concerned only with the volumes, I can come and use the volumes SSL, and it's going to give me, again, eastbound, westbound at each of these stations. So there are my quantities per station as defined by the clipping boundaries. And what I want to show now is, remember that I had that toggle turned on to display clipped graphics. So I'm going to come back here in my 2D model. I'm going to right click and go to 2D, 2 views, plan and 3D, get that 3D view up. And we see the 3D reference of everything that's coming in through the references. I'm going to turn those off to see the clip graphics that were drawn into this file. So let's go to, make our 3D active there, go to references, and let's just turn off the display of our references there. So the design references are turned off now. So what I have in here are clipped meshes at the station interval that I defined. So for example, if I wanted to come in and just take a quick look at the fill mesh, that's the grass, here's the fill mesh. If I wanted to go look at properties and see what kind of volume I'm talking about, I can click on it, and you notice that that's just 500 feet there. That's just that one clip boundary. So I have, on most of these commands, when I have that option to create clipped graphics, I can actually create a physical representation of the volume that's being reported, and it's good for me to see what's going on. It's another way I can QA the numbers that are coming out. And you'll also notice that it didn't just clip and write into the file the cut and fill graphics there. It actually, again, it took everything that had a feature definition on it. So it got part of my bridge here. It's taken my bridge elements and it's added those in. The lines for shoulder, if we had guardrail, it would copy that in and it would show the length of the guardrail, and it would show it clipped every 500 feet or every interval that I defined back in my drawing boundary. So that's a very powerful tool in and of itself. If I just need to slice up my components and my linears to represent for various station intervals, I can do that. It's not just doing the cut and fill unsuitable, it's doing every civil component here in the DGN file. And so if I wanted to see just cut and fill, I could go in and start playing with my levels, turn off my pavement levels, just leave on just my cut and fill levels, that kind of stuff. But like I said, a powerful tool. Everything is being split up for me at the station range I defined. Everything's being drawn in 3D for me. Okay, so everything I've talked about to this point is the real 3D prismoidal volumes. Now let's talk about end area volumes, and let me get set up for that real quick. I'm going to turn my references back on in my 3D view. Turn those back on. So here I have, again, my 3D model. It's got my cut and fill. It's got all of my design features referenced into it. So I want to now do some end area volumes. We understand that the best for sure is the 3D prismoidal, but we understand that there are some maybe agencies that are still relying on end area volumes. And maybe we just want to use that as a QA check. It's kind of an old methodology. It's not as precise, but since there's so many people still using it, people like it, we provided the option to do it here. And so let's talk about that. Let's talk about that method now. So to do that, the first thing we need is cross-section boundaries. And so the end area volumes report run off of cross-section boundaries. So that's the first thing I'm going to do here is go in and create cross-section boundaries. So we're going to go to Drawing Productions. I'm going to go to Name Boundaries, Create Name Boundaries. And this time we're going to create cross-section name boundaries, which civil cross-section is the type. This time I am actually going to create sheets because we're going to do some annotation of the cross sections after we're done quantifying them. So for drawing seed, I'm going to pick the ANSI D cross section seed, and let me go ahead and pick my path element here. Okay, and I'm okay with that name. What I want to do, I'm just going to do a portion of the roadway here because the calculations here can take a little bit. So I'm just going to do a portion of the roadway. We'll start here where we have some rock, and we'll just run up to where we have our bridge abutment and stop it there. And before I do that last data point, I do want to create my drawings. I'm going to do it at a 100-foot interval, 125 left and right. That ought to be fine. Okay, so I'm going to place those cross sections and accept. So it's going to place those name boundaries for me, and let's go ahead and get it churning out those drawings for me. While it's doing that, we'll just talk generally about how we do the end area volumes. We need these cross-section name boundaries. These cross-section name boundaries are going to tell it how often our end areas are going to be calculated. What it's going to do, it's going to go and look at the at the features that are crossing those cross sections. It's going to calculate the area. It's going to multiply it by the interval between the cross section boundaries, and it's going to report on that value for us. So, like I said, less precise than doing it with the Prismodal volumes, but it's been around forever. It's going to be around for a while more still. So right now, I'm not just creating the boundaries right now. I'm going ahead and creating the full sheet. So it's you see it down there at the bottom, the status bar. It's creating those sheets. It's referencing in the drawing models. And when I get done, it has actually created my sheets for me. Let's just look at this last one real quick. One thing I want to show here is I see my design features up here. I see my pavement buildup section. I've got my annotation in there already. I've got my unsuitable pavement thing there. So why am I seeing my fill shape there? That's in blue. Why am I seeing that? Well, because that is a 3D mesh in my 3D model. So when I cut a cross section through it, it cuts through it and it shows it on my cross section sheet. So that's good. That's a good way for me to see it there. So now that I have my my cross section named boundaries, I'm going to go back to our 2D model. And what I need to do now is run through that end area volume calculation. So what I'm going to go to is the home, and going to go again to the civil analysis button, and the end area volumes report is down here. So when I choose the end area volumes report, really I only have one option there: which named boundary group, which cross-section named boundary group do you want to use? Well, I'm going to use the one I just created, which was Highway 72. We can see them here in 3D, here in 2D. I'm going to use that for my calculations. So it's going to get the area of the shape. We'll go ahead and kick that off. I want that name boundary, and it does prompt me if there is any area that I want for volume exceptions. Then I can choose the start and stop of the cross-section name boundary where I want a volume exception. I don't need to do that right now because where I don't have any volumes going on underneath this bridge section, I just told my components that they were a volume option of none. So I don't have any areas where I need to do a volume exception. So I'm just going to reset at this prompt here. I want to just take a moment here to encourage everybody to read this prompt, because some people will see select the start and they think they're being asked for the start station. But if you read the rest of it, they're really wanting the location of any kind of volume exception, any station range where we don't want volumes calculated. So in my case, I'm not going to use that. I'm just going to reset here, and I'll let it now process through all those named boundaries. So it's doing a couple of things here. It is calculating the end area volumes based on the shapes at the cross-section boundary, and it is writing the cut, fill, and areas information onto the name boundary shapes themselves. Okay, so let's look at the report that's generated. We have our end area volume report, and we get the different stations that we chose, and the area, and then the fill on it. So here we have our end area volumes. Like I said, not just in this report, but we need to annotate in our drawings. We want to annotate the results of this as well. So I'm going to close out of this report. Like I said, when it ran the report, not only did it do the calculations and give me the report, but it wrote onto the actual name boundaries themselves. It wrote the values of the cut and fill on there. So now when I go and do some sheet annotation on my sheets, the data about the cut and fill values is available for me to be annotated on the sheets. So let's go just to one of our drawing models as an example here. We'll go to station 515. And now that the drawing name boundary has that information on it, I can annotate it. So I'm going to go to drawing production, going to go to model annotation, and I'm going to annotate this model using the end area volume annotation group. So in the annotation group, I'm going to pick cross-section, drawing, and I'm going to pick EAV, end area volume annotation. And right now, I'm not going to do all models right now. I'm just going to do this one just to look at it, see if it's good, and see what it gives me. because I knew there's something that I don't like here that we're going to fix in a second. So here we have the annotation. It's coming in as an annotation cell. It's giving us the cut area, the fill area, the cut volume. This is all customizable in your annotation group and how you set it up. You can put exactly what you want. You can set it up to put it anywhere you want on the drawing file. But you can see that in this data set that we're using in our standards that are delivered with the product, it's putting 2 tables in there. And I don't want the 2 tables, so let me just show you how to fix that. And it's a good thing to show so you can get an idea of where this is coming from, right? So we'll go back to our 2D model so that we can play with those. I'm going to hit multi-model views to get back to where we were. And I'm going to go look at that annotation group that it copied in here. We'll go to annotation groups, go to cross-section, drawing, and do cross-section end area volume annotation. That's the one we just used. I'm going to right-click on it and say Manage. And the problem was I had 2 tables there. And it's because in this annotation definition, we're telling it to annotate in 2 locations. It looks like we're prepared for the possibility that we might be doing left side versus right side. So we have a center line and a center line left. In my case there, I just have the one. So I'm just going to come in here and I'm just going to delete the center line left. I'm just going to leave 1 point in there to annotate. So what it's doing is it's annotating this. It's annotating with a cell. The cell has text favorites in it that are pulling the information out of the database off of those named boundaries. So the text favorites in the cell are pulling the specific values. And it's placing it at this location. And I only want 1 in my thing, so I'm just going to add the 1 center line there. So I'm going to close on that. I'm going to go back into one of my drawing models. Let's go into this one. And this time, now that I've fixed my annotation group, I like what it's going to place. I'm going to go ahead and do all the models. So I'm going to go back to model annotation, and I'm going to, when that comes up, this time I'm going to toggle on, yes, all drawing models. I'm going to pick that end area volume annotation definition that we just edited and place it, and go ahead and place it there. So now what it's doing is it's going through every drawing model that we cut with our cross-section set. It's putting the annotation that we define in that annotation group in there. And now I have just the 1 table of the cut area, cut volume, fill area, fill volume. There. And again, like I said, this is fully customizable in how you set up the cell, the text favorites, the annotation definition. So there, we have calculated end area volumes, we've run a report on end area volumes, and we've annotated end area volumes. The last thing I want to do is, and it looks like our time is working out well. The last thing I want to do is go and create a mass haul diagram for my volume. So I'm going to go back to my multi-model views. That gets me back here to my 2D. I know that command is going to ask me for a center line. That's why I came back here. And so here we are. I'm back in the DGN. I have the volumes referenced in. I'm going to go back again to the home modeling analysis, and this time we're going to choose mass haul diagram. So there's a few different options on the mass haul diagram. Really powerful, these different options. We can just do a defined interval along the alignment that we choose. I can use that cross-section boundary that I just created, or I can use plan boundaries that I created. So I can do mass haul based off of these left and right plan boundaries that I did earlier. So there's just a ton. However you need that data broken out and reported, you have a method for you. And not only that, you have the option down here at the bottom again to clip it based off of that and display the physical representation of those volumes that you're reporting on. Okay, so in our case, I just want to show the interval method. So I'm going to pick method interval. Then it's going to prompt me for the alignment, and I'm just going to say, just do the beginning of my roadway here. I'm going to do a 100-foot interval, and I'll just do a beginning portion of my roadway from there to there. Again, I could key in specific stations if I needed to, but I'm just doing data points for speed. Going to say 100-foot interval. I choose a left and right offset off of that alignment that I chose. And let me show you, before I do that, it's going to ask me what annotation group do I want to use. So the annotation group here I want to pick is in Profile, Drawing, and I want to use the Mass Hall diagram annotation group. This annotation group has some things like the axes, the grid, the labeling on the axis. Everything is set up there in the annotation group, so I'm going to pick that. And then I'm going to finish and do my right offset and my vertical exaggeration. Again, here's where I choose that annotation group. Since I selected it now, it did copy it into the file, and that's why it's there. And then the last thing it asked me is, what do you want the model to be named? What's going to happen when I finish with these prompts is it's actually going to create a new model in my DGN for that diagram. That's going to be the name of the model that creates. And at this point, I don't want to display any of those clipped graphics on this. I really just want the diagram itself. And so again, it's doing quite a bit of computation here, going through at every interval, looking at the 3D meshes and calculating the volume at that interval, and then reporting that back out. And then at the very end, it'll go in and draw the diagram for us. Okay, so now that I ran that, here I get my report. Very simple, station and volume on that. And then this basically is plotted out in our model for it. It used all that information from the annotation group that I selected, which includes, axis labels. We're telling it to put vertical dotted lines for our major axis, just ticks for our minor. We gave it a label there, and here is the plot actually then of that. We were in a little bit of cut there at the beginning, then or a little bit of fill, then we're in some cut, and it's plotting that diagram for us. So this is a model now in our DGN file using that model name that I gave. So.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.